Good morning, Pre-Calculus. Today is March 26th, and we are doing 7.3 double angle, half angle, and product sum formulas. Open your book to page 541, date and title your notes today. Now, a double angle formula, a half angle formula. What is a double angle? What is a half angle? Now, you don't have to draw this out, but I'm going to give you a quick representation. Here's an angle, maybe it looks like 50 degrees or so. Literally doubling the angle, okay? Half angle, literally taking a half of that there, okay? Half angle, double angle, just like it sounds. We have the benefit of using formulas. These are going to give us exact answers for what that resulting angle is going to be or what that position on the unit circle is going to be, okay? So let's go back, the next page. 542 gives us these formulas. So we have for sine, for cosine, and for tangent. Now there's three different versions of the cosine double angle. You can use any one of those three, whichever one serves you best for that problem. You can use any one of those three for the cosine double angle. All right, so copy these down, put a sticky note in your book on page 542. You'll need to use these, especially in tonight's homework, obviously, and then these do not have to be memorized. They will be used on the quiz, but you do not have to memorize. They'll be provided. Today we'll also be needing our 7.1 fundamental trig identities, the reciprocals, the identities, and the Pythagorean identities especially. So if you have those handy, I would take those out and have those ready nearby for today's lesson and the homework as well. Okay? So example 1 is going to be on page 542. And we are asked to find double angles, both the cosine double angle and sine double angle. So we're given, hey, cosine x is -2/3. Okay, but now find the double angle of cosine and the double angle of sine. All right, well, let's start with our double angle of cosine. So I went to my formulas and my formula list. I chose the third one of those cosine formulas. There's three. Notice I'm only given cosine. I don't know sine. So those first two cosine double angle formulas would be a little hard to use right away because I don't have sine. I could just make more steps for myself. So I'm going to choose that third cosine double angle formula to use to find my cosine double angle. So I copy down that third one, which doesn't include sine in it. And now I'm going to plug in. I know my cosine x. Cosine x is -2/3. And in the formula, cosine squared x, that means you take what cosine x is and square it. So cosine x is -2/3. So I'm going to square -2/3. Plug that into the formula. -2/3 squared gives you negative times the negative is a positive. 2 times 2 in the numerator gives you 4. 3 times 3 in the denominator gives you 9. Okay, 2 on the outside, multiply, -1 on the outside. You get 8/9 minus 1 gives you a -1/9, and so we can say our cosine double angle is -1/9. Okay? You can pause that if you need that. Now, we always go back and we check our answers. Did we answer the question? Should we double check our work? Well, let's think. Let's go back up. Oh, find double cosine. Ooh, we did, but it says and sine 2x. We didn't find sine 2x yet, so we're not done. Next page, we're going to use what we know. We know cosine are given. Cosine x is -2/3, and we have to find 2x. Sine 2x. So I'm going to go to my sine double formula. There's only one. The first one of that box we copied down. Sine 2x equals 2 times sine x times cosine x. So I'm going to put, we don't know sine yet. We don't know sine. So we need to find sine. And so what I did is I went to my list behind us, that 7.1 trig identities, and right there, Pythagorean identity. I have to rearrange that because I have cosine, but I don't have sine, and I can find it. So I rearranged that identity. being, here's the Pythagorean trig identity, sine squared x plus cosine squared x equals 1. And then I subtracted the cosine from both sides, and I took the square root of everything on each side, and I got a single sine x equals square root of that, 1 minus cosine x squared. Okay? And so now I have this, I can find a sine x. I can't plug into this formula yet. I want my sine double x, double angle, but I don't have a sine. So this allows me to find the sine. So I know cosine is negative 2/3, so I'm going to plug that in and square a negative 2/3. So we've got our negative 2/3 squared gives us a positive 4/9. 1 minus 4/9 gives us 5/9 inside the radical. We can distribute that radical to both the top and the bottom, and then the bottom reduces square root 9 to 3, and we have our sine of x is that square root 5/3. Now I can take that sine x square root 5/3 and plug it in right there now so that I can find my sine double angle. You can pause this here if you still need this. I'm going to flip to the next continued page. So the information we have, we just found our sine. We were already given our cosine from the beginning, so now I can plug into that sine double angle formula. When we do that, we're replacing the sine x with what we just found sine x to be and what cosine x was given as. And then we're multiplying. That's a 2/1 times a fraction, multiply straight across the numerators and then straight across the denominators, and you get negative 4 times radical 5/9. You would check if you can reduce it. In this case, we can't any further, and that is your sine 2x. So now we've finished, we've answered the question. Okay, you can pause that there if you need that. All right. In the homework, they tell you the quadrant that you're starting in, and it's really just to help you. If it says, hey, you're starting in quadrant, let's try this again. If you're starting in quadrant 1 and your x is negative and you're doubling that angle, it might be that your y is going to now be negative. Just something to think about. So telling you the quadrants, that's really helping you identify and know what answers are going to be positive and negative coming out of it. Okay? So don't worry too much about it when it says quadrant 2 in the homework. It's kind of just giving you an indicator if your positive or negative is correct or not. Okay, so I'm going to come back to that one. Let's do, this is going to be homework question number 6, and I'm doing it on page 548. So page 548, homework question number 6, I'm going to do for you. So secant, it's given, secant x equals 2. So we know secant x equals 2, and we're asked to find all 3 identities. We're asked to find the cosine double angle, the tangent double angle, and the sine double, all 3. I don't know if I named them all. Sine, cosine, tangent, double angles of all 3. Okay, so we're starting with secant. Well, secant isn't in any of the ones that we want, but maybe we can use a identity, a trig identity. We have cosine equals 1 over secant. Cosine equals 1 over secant, and secant equals 1 over cosine. So this is just the identity of cosine, and this is a reciprocal identity for cosine. So we can use that to rearrange and find our cosine. So we're given this, I want to know cosine. So our cosine, x is 1/2, easy enough. Next, we want to start finding, we need sine so that we can plug into a formula. So from the Pythagorean identity, the sine x squared plus cosine x squared equals 1 is just rearranged for sine x squared, and that's going to be what we can plug into. We have cosine. cosine is 1/2 we just found, so we're going to square the 1/2, and we get 1/4. 1 minus 1/4 is 3/4. Distribute that radical to both the numerator and the denominator. You can then reduce that denominator to just a 2, and we've solved our sine x to be that square root 3 over 2. Now I have my sine right here, and I have my cosine up here, so I can now plug into the double angle formula for sine, which requires both knowing the sine and the cosine. So I know my sine, I've plugged in square root 3 over 2. I know my cosine, I plugged in 1/2. Formula is 2 times that, and we've got one pair of those 2's cancel. That's a 2 over 1 and a 2 in the denominator. Those cancel, and we have a square root 3 over 2 is our final answer. Okay, so we've got the double angle for sine, and we still need to find the double angle for cosine and the double angle for tangent. Let's do double angle of cosine next. So I've written down the formula, I've picked one. I know what cosine is and what sine is, so I'm just going to square each of those. We know cosine is 1/2 and sine was square root 3 over 2, so we're just going to square both of those with a subtraction sign in the middle because that's the formula. We got 1/4 and 3/4. Remember, when you square a radical, it just drops the radicand around it and it just becomes the inside. And now we have like denominators, so we can subtract those fractions. So 1 minus 3 gives us a minus 2 in the top, and we'll reduce that. Our cosine double angle is -1/2. Okay, we've answered 2 of the 3 parts of this question. Now comes our last part, tangent double angle. So here's our formula for our tangent double angle. And we need to remind ourselves, what's the identity for tangent? Well, that's sine over cosine. And so I rewrote that formula. Our formula, so it was 2 tan x on top. I rewrote it as 2 sine over cosine. In the bottom, it was 1 minus tan squared. So I rewrote it as 1 minus sine squared over cosine squared. Write really big quotient lines for the middle one so you don't get mixed up, because there's really 3 quotient lines there. Crazy, I know. All right, and then we reminded ourselves, we found cosine was 1/2 and sine x was square root 3 over 2. So we're going to plug in. Let's do it this way first. Okay, so when we plug in, we've got sine divided by cosine. Sine divided by cosine. So our square root 3 over 2 divided by 1/2. And then in the denominator, same thing, sine over cosine, but we're squaring those because the formula said to square them. So each of those fractions are squared. And we're going to do some keep, change, flip in the denominator and the numerator respectively. So here's the 2 over 1 out front. I've got my numerator, that's the keep. I'm changing that division sign to a multiplication sign, and that 1/2 in the denominator, I'm flipping to a 2 over 1. And then I can cross out a pair of 2's, one on top, one on bottom, reduces to just 2 square root 3. And that's the big numerator. Now down to the big denominator, copy the 1 minus. That's just part of our formula. So we're squaring square root 3 squared, just drops the radical and gives you a 3. This is part of our keep for the first fraction. Divided by, and that's over 2, so square the 2 and you get the 4. So that's our keep on the top, which we squared. Change the division to that multiplication there, and then on the bottom we're going to flip. Careful when you flip, don't forget to also square. That's not 1/2, that's 1/4. So we square it, and then we reciprocal it, so we have 4 over 1. Again, we have a pair, one in top, one in bottom. Those can cancel out, and we have, that becomes 3 over 1. Don't forget the 1 minus that was out front, so 1 minus 3, giving us that minus 2. Okay, and then I've rewritten this. So 2 square root 3 that we found is our in the numerator, and then -2 we found in the denominator. You can cancel those 2's and move the negative out front, and your final answer for double angle of tangent is -square root 3. Whew, all right, we're done. That example had 3 parts. If you need to copy that, you can pause that now. All right. Now, we were kind of lucky. Our starting angle was, we were given secant 2, which is a nice number because cosine was 1/2. 1/2 is nice. It's a half. It's positive. It's easy. I won't give you one this hard, but I just want to give you an idea of what this is going towards. So say you were given sine x of, and you don't have to copy this one down, of 7/8. It's a pretty big denominator, that 8 there. We're asked again to find all 3 double angles for sine, cosine, and tangent, all 3 of those. I started with my sine double angle formula. We don't know cosine, so then we went to our Pythagorean identity there, rearranged it to solve for cosine, plugged in the 7/8 for sine, and squared it. Yikes, we got 49/64. It's pretty big. Just do your algebra there. To reduce that, you get square root 15/8. That's just our cosine. We haven't even found the double angle yet. So now that we have the cosine, now we can plug that in to the double angle for sine. Okay. So I rewrote what we just found, cosine, and what we were given, sine. And then I wrote out our sine double angle formula. And now we can replace sine x with 7/8 and the cosine x with the square root 15/8 now that we know what that is. And then just multiply it out. That's 2 times the numerators and the 2 denominators. Multiply it, reduce it, just your simple algebra, and you've got your sine double angle. And don't forget, you got a shortcut in your calculator. That second, if you hit math, enter. That'll change your, it'll give you a fraction, a reduced fraction. So if you're doing, I'll show you that one right there. Right, so I did 2 times 49 divided by 64, and instead of hitting enter, I went and I hit the math key there. When you hit that math key, it brings you to this screen and you just hit fraction. You just hit enter there. Okay, and it'll enter the word fraction. Okay, all right, back to this. Simple math, reduce your fractions, and you get, here's our double sine angle. Okay, so we now got double sine. Let's find our double cosine. We know we could have found this one first before we found double sine. That's fine. I just chose to do sine double angle first. So cosine double angle, here's our formula. I just happened to choose this one. I could have chose the one that had sine in it also, but I just chose this one. Square what cosine x is, times it by 2, subtract 1, do your little algebra, reduce your fraction, you get 17/32. And then this one is tricky. And I'm not going to make you, and this is why I'm not going to give you a problem like this, I'll just show you a glimpse of it. For tangent double angle, it gets really funky with all these gigantic fractions divided by fractions here, and then trying to reduce, I just stopped doing it because I got to a point where I realized I'm not going to make you guys do this problem. So, but just to kind of give you another idea, another example there. We're not going to do the half angle examples just for sake of time today, but it's the same thing. You just plug into a formula and you use your fundamental trig identities, and you do your transformations and you do your fractions and multiplying and all your algebra to get to your answer, and you'll be good there. So I think I'm only going to assign a couple questions because there are 3 parts, but I really want you to try and use that critical thinking, use the grit, use your lateral thinking, and try and figure these out and try and get your correct answer. And so I am going to give you odds, or part of them odds, so that you can check your answer and get that satisfaction that you did it right, because you may have multiple pages of work and it'll be good to know whether you're doing it right or not, and you're showing your work anyway, so it's okay if I give you the answer. You're showing all that work anyway. So look in RenWeb, and I'll post the homework questions that are going to be due in there. All right, thanks guys.